Understanding fax transmissions. In the world of fax, they're a little more sensitive than when it comes to people. When people are talking on a phone system, if there's any issues, usually they'll ask for a repeat, and if there's something wrong, they rarely result in a nasty message. Fax technology is a little more sensitive, however. When faxes are talking across, if there's any blurbs or any problems that are happening, they'll result in some type of transmission error. This is compounded by the fact that they are working typically across the globe or across the nation. The faxing protocol has been identified by ITU and it is called T30. To best understand this, we'll need to break it down into the different 5 phases of a fax. You can see how they're identified with letters: Phase A, Phase B, Phase C, Phase D, and then Phase E. Depends on what's going on, you'll have different types of transmission messages and error messages and alerts. Depends on what part of the call we're either successfully working at or breakdowns are at. There is a lot of details to how this works, so we'll do a high-end overview, but this is a technical breakdown and deep dive to this process. Some terminology that comes up that we'll need to understand is basically when it comes to fax bit rates, or really just the speeds. You'll see 2 terms that come up a lot in faxing: V17 and V34. V17 refers to a maximum speed of 14,400, which is a pretty slow speed, but that's as fast as a typical fax will go. V34 refers to 33,600, which is a lot faster, actually over double. The first section here, V17, is referred to as G3, which is called Group 3 faxing, which is the standard for most fax machines that are in the world. V34 is referred to as Super G3, which is a different method altogether. Uses similar concepts as G3, but some enhancements that help to go to faster speeds. The first one we'll look at is Phase A. This is the call establishment. This quite simply is whether the fax machine will identify itself as a fax machine. So if you had a multifunction device that can answer phone calls and faxes, and you were to call it with a fax machine, and a human answers, should it go into the fax process or not? The calling fax machine uses a tone called CNG. This is called a comfort noise generation, and it simply identifies to the other caller that you're in fact a fax machine and not a person. The fax machine that answers the call will make all the difference on what type of speeds that we're using. The CD tone, kind of a flatline sounding pulse, indicates that it's a G3 only system, that it can go as fast as V17, which is 14,400 only. If you were to call a fax machine and it made that tone, that means that it's as fast as you can go and you are not capable of the V34 speeds. If the fax machine answers with an ANSAM signal, this indicates that it is Super G3 capable, but it does not force it to be at V34 speeds. This means that it is capable of it based on negotiation from the other side. At this point, if the sending fax machine is capable of Super G3, they'll go through a V34 negotiation stage. There's really 3 phases for this. The first one is really simple: network interaction. The calling fax machine hears that ANSAM pulsating tone and responds back, and they negotiate whether they can do V34. If they agree they can, they move into phase 2 of the V34 phases, which is called line probing and ranging. This is an exchange of capabilities, determines on the round-trip delays, determine a bandwidth, and signal-to-noise ratio. Then they moves on to phase 3, which is the actual sending information back and forth. This is done through a primary channel equalizer training, modulates and demodulates, goes back and forth, and if there's any issues that go, it moves itself back into phase 2 if there's some problems. Once this is all determined, whether you're using V17 or V34, we move into the phase B stage. Phase B is where we negotiate what we can do and what we can't do. On the actual calling of a process, the answering fax machine will initially respond with something called a CSI and a DIS. The CSI is a called subscriber identification. This is really just their name. If I was sending you a fax and you sent me a CSI, I would see on my display a little tiny CSI information would show up, which would be your information, your company name, or whatever you choose to display. The DIS is your capabilities, your compression rates, your speeds. What are you configured to be able to do? That's what the called fax machine will respond with. The calling fax machine will then respond with its own information, which is the TSI, the transmitting subscriber identification, basically its name that it's sharing, and then something called the DCS. This is the digital command signal. This is basically the response to the DIS. So out of the list that you've told me, This is the list that we're going to use based on that list. When that's finished, it's something called a TCF, a training check, which is just a quality of sound sending across. V34 does this in their line probing, so that's not included with V34. In the Phase B process, once this is finished, the remote side will then respond with whether that sound check did work or not, which is a CFR, and if it did not work, if they were sent up a quality issue, we'll respond with an FTT, which is a failure to train. If we get an FTT, we will not pass the Phase B section, and we won't move into any other stages. If we do, however, we'll move into Phase C. Phase C is really just the message transmission itself. This is the sending of the fax itself, the body, the pages, how it's encoded and sent. The sending device will start off with a short training, which is basically checking the quality once again, a resync, and then it'll break apart the fax images and send apart in little frames. What we're looking at here is something called error correction mode, where the frames are sent and then tracked, and then an account is sent after the fact that can be measured and responded back in. When it's finished sending a bulk of information in frames and it considers it enough to send, it'll respond with 3 identical RCP informations, which is return to control for partial page, which basically means I'm finished with this particular section. The Phase D process is a response to that information. So with the same error correction mode enabled, we get those 3 RCP sent from the actual sending side. It'll then finish with giving a partial page signal. This is basically a checklist of how many frames were sent and what was involved. What you can look for: page count, block count, and frame count. If the receiving side sees the amount of frames that came in and determines it's the same amount that was received that it was sent, it will respond with an MCF, which is a message confirmation. If, however, there's something wrong in that count, it'll respond with a PPR, a partial page request. This means there's something wrong with that count and you need to resend, and it will also respond with which frames were missing. When you're not using error correction mode, those frames are not counted and they can't be measured. So basically how this works is all the information is sent, and you'll see it as a T4 non-error correction mode data, and afterwards it'll let you know whether there's more pages or not. This is an MPS, meaning a partial page signal. When the final information is sent, it should send an EOP, which is an end of procedure. If it doesn't work, we'll get a response like RTP, retrain positive, or RTN, retrain negative. RTP indicates it did work, but there's some concerns. So let's go back to Phase B and renegotiate our speeds and our different information. RTN means it didn't work at all. We need to go back to Phase B altogether. When this is finished, we go to our last stage, which is Phase E, which is really simply a disconnect of the call. It is actually possible to get a transmission error at the Phase E process if this disconnect is not received in a timely manner. So you could receive all your pages of every bit of your fax coming across. If the DCN isn't sent properly, you can get a transmission error even though the fax worked. These are the 5 phases of the fax process according to the T30 ITU standard. Hopefully this is helpful in helping you troubleshoot fax processes in the future.